Hi, I'll show you how ConstructOS turns a prompt into a working product. It uses a spec-driven approach where AI generates the specification from chat. In this demo, we build a Galaga-style browser game. After entering the prompt, ConstructOS generates a specification and tasks. Work runs in 3 phases, each deployed and validated by QA. Tasks are grouped into 3 phases. Work flows through Git, then deployment and QA follow each merge. Here is the specification, the single source of truth. It defines what to build and is implemented through 9 tasks. Implementation has started, and we can track progress on the board in real time. At any time, we can open a task to inspect its current state. We can see what the agent has already completed, what it is currently working on, and how execution is progressing. In the Project Details view, we can access key information about the system. This includes the team lead, the repository inspector, and the current state of the code across different branches. If human review is required, we can also perform code review directly here as part of the same workflow. We can also see Docker container details, and the application is not yet deployed. We continue tracking the implementation as Phase 1 moves toward completion. At this stage, the team lead prepares and performs deployment, ensuring that everything is ready for release. Once deployment is complete, the QA agent takes over, runs validation, and checks the application behavior. If everything passes successfully, the first phase is completed and the system is ready to move forward. We can now test the application and see how it looks. The MVP is already functional and successfully deployed. Phase 2 of the implementation now begins. At this stage, the application continues to evolve using team mode, where multiple agents collaborate as a coordinated execution system. In this setup, 4 agents are involved: 2 developer agents writing and updating the code, a team lead responsible for review and coordination, and a QA agent validating the application after each change. Each task moves through this structured flow, ensuring work is properly implemented, reviewed, and tested. This approach simulates a real engineering team, where responsibilities are clearly defined and execution is controlled and traceable. We can see that the application was deployed after Phase 1. In the Docker Compose Runtime Inspector, we can view deployment details and monitor real-time logs as the system is running. We now follow the deployment of the second phase. Each task moves through the system from developer to team lead, and then, when needed, to QA, depending on whether it represents a deployable slice. This ensures that only validated work is released. Once all tasks in Phase 2 are completed, the system triggers deployment again and prepares the next iteration. We can see that the application has been deployed again, this time with all the changes introduced in Phase 2. Compared to the initial MVP version, the application is now noticeably richer, with more features, improved behavior, and a more complete user experience. We now move into the third and final phase of implementation. Through the UI, we can track the current state of all tasks while also monitoring the status of the deployed application in real time. In addition to the board view, there is also a list view for tracking work. We can switch the application to a terminal-style dark mode and monitor execution through the COS console using MCP tools. The system also sends real-time in-app notifications, keeping the user informed whenever attention is required. The core value of the system lies in the knowledge graph. It connects all relevant information from the project, including specifications, tasks, notes, and event storming analysis, into a unified structure based on domain-driven design concepts and relationships. Through this graph, we can clearly see how different parts of the system are connected, how data flows, and how responsibilities are distributed across components. The visual diagrams allow us to explore and analyze the system in depth, making it easier to understand complex interactions. If the model incorrectly identifies certain elements or relationships, we can review and adjust them directly, ensuring that the system remains accurate and aligned with our expectations. All of these elements, including graph data, relationships, tasks, specifications, and notes, are indexed and searchable using vector search. The most important parts of this data are embedded into each agent's context, making their work more precise and relevant than a standard prompt-based approach. Through the UI, we can inspect this context in detail and clearly see what ConstructOS agents know about the project. We now return to follow the implementation of the third and final phase. This phase completes the full delivery of the application, bringing together all previous work into a stable and production-ready state. As execution progresses, tasks move through the system until everything is finalized. Once all work is completed, the system automatically generates a final report as a note, summarizing the implementation and capturing key results. At the same time, the user is notified that the process is finished, providing a clear signal that the application is ready. At any time, including at the end of the process, we can interact with the system through chat. We can request additional changes, generate reports, or guide the execution by providing new instructions. This allows us to directly influence ongoing work, while everything remains within the same workflow. We request a report with diagrams to summarize the current implementation as a note. We notice that the application was not successfully deployed in the third phase, so we request an analysis of the issue and ask the system to resolve the problem before proceeding. In the meantime, we review the generated reports and the additional mermaid diagrams created by the system. These diagrams are deeply integrated into the application, providing a clear visual representation of the implementation. They help us better understand the structure, follow the flow of execution, and enrich the overall content with meaningful insights. We can now see that the application has been successfully deployed after completing the third phase. At this point, the system is significantly richer, with improved visuals and enhanced gameplay elements, including more detailed spaceship graphics. It now looks and behaves like a production-ready application, similar to the classic arcade games it is inspired by. However, we notice that something is not working as expected. There is a bug in the application, where enemies are not shooting at all, which directly affects the gameplay experience. We report the issue through the system and immediately trigger a new step in the workflow. The agents pick up the problem, analyze it, and begin working on a fix without interrupting the overall process. The issue has now been resolved, and the application has been redeployed with the fix applied. We can see that enemies are now shooting correctly, which restores the intended gameplay behavior. This means the game is now fully functional, and the player can actually be defeated. And that's it. From a single prompt, we achieved a complete working product, with every step automated and fully tracked for auditing. ConstructOS also provides capabilities for building AI-first applications. You can interact with the system using voice and extend it through skills that enrich the context. The platform is currently in beta, so feedback is welcome and issues can be reported through GitHub. This is ConstructOS. Request onboarding on the website.